Where does your mind actually exist? This is not merely a poetic or psychological question, but a profoundly physical one. We are accustomed to locating objects in space, events in time, and processes in matter, yet the mind resists this tidy categorization. It is not simply a thing among things, nor a ghostly spectator watching the machinery of the brain from some hidden balcony. Modern science often encourages us to believe that the mind is nothing more than computation, a complex arrangement of neurons performing algorithmic operations. But there is a subtle difficulty here. Computation, as we understand it, is rule-based and finite in nature. Human understanding, by contrast, repeatedly demonstrates an ability to grasp truths that no fixed algorithm can exhaust. Mathematical insight, for example, involves a direct apprehension of meaning, an act that transcends mechanical symbol manipulation. This suggests that the mind cannot be fully confined to the classical physical world as it is usually conceived. Instead, it seems to participate in a deeper structure of reality, one that connects physical processes with abstract truth. Mathematics, in this view, is not an invention but a discovery, hinting at a Platonic realm that exists independently of our minds, yet is mysteriously accessible to them. The brain, of course, plays an essential role. It is the physical arena in which mental activity is expressed. But expression is not the same as origin. A violin does not create music by itself, it allows music to manifest. Similarly, the brain may be the instrument through which consciousness appears in the physical world without being the ultimate source of conscious experience. If this is so, then the mind may exist at an intersection, where physical law, mathematical truth, and conscious awareness meet. Quantum theory, still incomplete in its interpretation, hints that reality, at its most fundamental level, is not fully describable in classical terms. It is at least conceivable that conscious understanding is tied to aspects of physical law we have not yet properly understood. This perspective does not diminish science, it enlarges it. To ask where the mind exists is to ask how deep our physical theories must go to account for understanding itself. The answer may require new principles, ones that treat consciousness not as an afterthought but as a fundamental feature woven into the structure of the universe. In seeking the location of the mind, we may ultimately discover that it is not located in space in the usual sense at all, but rather in the subtle harmony between physical reality and timeless truth. The idea that the mind can be fully reduced to computation is deeply appealing in an age dominated by machines that calculate, optimize, and simulate with astonishing speed. If the brain is a physical system, and physical systems follow laws, then it seems natural to assume that mental activity is nothing more than an extremely complicated algorithm running on neural hardware. Yet this assumption quietly overlooks a crucial distinction between performing a computation and genuinely understanding what that computation means. A computer, no matter how powerful, manipulates symbols according to predefined rules. It does not know what those symbols refer to, it simply follows instructions. Human thought, however, routinely involves grasping meaning. When a person understands a mathematical proof, they are not merely processing symbols step by step. They perceive why the argument works, recognize its necessity, and see connections that were not explicitly stated. This act of understanding has a holistic quality that cannot be captured by a fixed sequence of operations. This becomes particularly clear when considering the limits of formal systems. In mathematics, it is known that within any sufficiently rich system of rules, there exist true statements that cannot be proven using those rules alone. A purely computational mind, bound to a specific algorithm, would be confined to the truths derivable within that system. Yet human mathematicians are capable of stepping outside such limitations, recognizing the truth of statements precisely because they see the structure of the system itself from a higher vantage point. Such insight suggests that human understanding is not exhausted by algorithmic procedure. It involves an ability to reflect on rules, reinterpret them, and sometimes abandon them altogether in favor of deeper principles. This creative leap is not random, nor is it merely statistical pattern matching. It is guided by insight, coherence, and an intuitive sense of truth that resists formalization. If mental activity were entirely computational, every act of understanding would, in principle, be reproducible by a machine following the same algorithm. But understanding is not merely about producing correct outputs. It is about knowing why those outputs are correct. This why is not something a computation can answer for itself. It exists only for a conscious agent capable of interpretation. This does not imply that machines are useless or that the brain does not compute. On the contrary, computation clearly plays an essential role in cognition. But to mistake this role for the whole story is to confuse the map with the territory. The richness of human understanding, especially in abstract thought, points beyond computation to something more subtle at work. The mind, therefore, appears to operate in a domain where rules are not merely followed but comprehended, where symbols are not only manipulated but infused with meaning, and where truth is not just derived but directly recognized. The attempt to locate consciousness within the familiar coordinates of space and time has long guided scientific inquiry, yet it repeatedly encounters a conceptual obstacle. Objects can be measured, weighed, and assigned positions, but conscious experience does not present itself in this way. A thought has no length, a feeling has no mass, and an idea cannot be pointed to in the same manner as a neuron or a region of the brain. This mismatch suggests that consciousness may not be something that occupies space in the conventional physical sense. Neuroscience has made remarkable progress in correlating mental states with brain activity. Specific patterns of neural firing reliably accompany perceptions, memories, and emotions. However, correlation should not be mistaken for identity. The presence of a neural process alongside a conscious experience does not explain why that process should be accompanied by experience at all. One can describe every electrical and chemical interaction in the brain without ever encountering the subjective quality of awareness itself. This difficulty reveals a deeper issue in how physical theories are typically framed. Classical physics is built upon quantities that can be externally observed and objectively measured. Consciousness, by contrast, is known only from the inside. It is the very medium through which all observations are made, yet it does not appear as an object among those observations. Treating it as though it were merely another physical component risks overlooking its fundamentally different status. If consciousness cannot be straightforwardly identified with a location in the brain, this does not imply that it floats independently of the physical world. Rather, it suggests that the relationship between mind and matter is more subtle than simple containment. The brain may be necessary for conscious experience, but necessity does not entail equivalence. Just as a broadcast depends on a receiver without being stored inside the circuitry, consciousness may depend on physical structures without being spatially localized within them. This perspective challenges the assumption that everything real must be spatially situated. Mathematical entities, for instance, are not located anywhere, yet they are indispensable to our understanding of the physical universe. Their reality is not diminished by their lack of spatial position. Consciousness may belong to a similar category, real and causally significant, yet not fully describable in spatial terms. When we insist on locating the mind as though it were a physical object, we may be asking the wrong kind of question. The more appropriate inquiry may concern how conscious experience relates to physical processes without being reducible to them. This requires a conceptual framework in which reality is not exhausted by what can be externally measured. By recognizing that consciousness resists simple physical localization, we open the possibility that our current picture of the universe is incomplete and that a deeper understanding of reality must account for both the measurable world and the inner domain of experience that gives that world meaning. The nature of mathematical truth raises a question that reaches far beyond numbers and equations. When a mathematical fact is discovered, it carries a sense of inevitability, as though it could not have been otherwise. This feeling is difficult to reconcile with the idea that mathematics is merely a human invention, shaped entirely by cultural habits or neural conventions. If mathematical truths were invented, one might expect them to be contingent or flexible, yet they appear strikingly objective and universal. Consider a simple mathematical statement. It is true regardless of who examines it, when it is examined, or even whether any human being exists to think about it. Civilizations separated by vast distances and histories arrive at the same results, not through agreement, but through discovery. This convergence suggests that mathematical structures are not created by the mind, but encountered by it. The mind seems to uncover relationships that are already there, waiting to be understood. This sense of discovery points toward the existence of an abstract realm of mathematical forms that does not depend on physical reality for its existence. These forms are not located in space, nor do they evolve in time, yet they exhibit an internal consistency and richness that rival the physical universe itself. They are timeless, precise, and indifferent to human affairs, yet paradoxically accessible to human thought. The remarkable effectiveness of mathematics in describing the physical world further deepens this mystery. Equations developed through abstract reasoning often find unexpected application in physics, sometimes decades or centuries later. This uncanny alignment between mathematical structure and physical law suggests that the universe itself is deeply mathematical in nature. It is as though physical reality is guided by principles that belong to this abstract domain. The human mind occupies a curious position in this arrangement. It is a physical system governed by biological processes, yet it can access timeless mathematical truths that seem to transcend the physical world. This ability cannot be easily explained by evolutionary utility alone, since much of higher mathematics has no obvious survival value. Instead, it points to a deeper connection between consciousness and abstract truth. If the mind were merely a byproduct of physical processes, its access to such a realm would be difficult to account for. How could a purely material system grasp truths that are not material? The fact that it does so suggests that the mind participates in some sense in both the physical and abstract domains. It serves as a bridge between concrete reality and timeless structure. This perspective reshapes our understanding of knowledge itself. Knowing is not simply constructing models that work, but aligning thought with truths that exist independently of us. In recognizing mathematical truth as discovered rather than invented, we begin to see the mind not as a closed computational machine, but as an instrument attuned to a deeper order underlying reality. The comparison between the brain and an instrument offers a useful way of rethinking the relationship between physical processes and conscious experience. When we observe brain activity accompanying thought, perception, or emotion, it is tempting to conclude that the brain produces the mind in the same way that a factory produces goods. Yet this analogy may be misleading. Production implies that consciousness is assembled piece by piece from neural components, but the lived experience of awareness does not resemble such a construction. An instrument does not generate the music it plays. It shapes, constrains, and gives form to something that already exists as an abstract possibility. A violin determines the timbre and range of sound, but the music itself is not stored inside the wood or the strings. In a similar way, the brain may provide the physical structure through which consciousness is expressed, without being the ultimate source of conscious experience itself. This distinction becomes clearer when considering the qualitative aspect of experience. Neural processes can be described in terms of electrical impulses, chemical gradients, and firing rates. None of these descriptions, however detailed, contain the redness of red, the sharpness of pain, or the sense of understanding an idea. These qualities appear only when experience is present. The brain seems to enable these experiences, but it does not explain why such physical processes should give rise to subjective awareness in the first place. Damage to the brain can profoundly alter consciousness, just as damage to an instrument alters the music it can produce. This dependence is often taken as evidence that the brain creates the mind. Yet dependence alone does not establish identity. A broken radio distorts or silences a broadcast, but this does not imply that the broadcast originates inside the circuitry. The radio is necessary for reception, but it is not the source of the signal. Viewing the brain as an instrument shifts the focus from generation to mediation. Consciousness may require physical structures to appear in the world, but its nature may not be reducible to those structures. This perspective allows for a non-trivial role for biology without insisting that biology is the whole story. It preserves the importance of neuroscience while acknowledging that explanation may not be exhausted by neural description. Such a view also accommodates the unity of conscious experience. The brain is composed of countless interacting parts, yet consciousness appears as a coherent whole. If awareness were merely the sum of independent neural activities, this unity would be difficult to explain. An instrumental model suggests that coherence belongs to the phenomenon being expressed, not merely to the machinery enabling it. This way of thinking does not require invoking anything supernatural. It simply recognizes that explanation may operate at multiple levels, and that the deepest features of reality may not be visible at the level of physical mechanism alone. The brain, extraordinarily complex and finely tuned, may be the means by which consciousness enters the physical world, shaping its expression without exhausting its origin, allowing awareness to take form through matter while not being identical to it. The success of modern physics has been so extraordinary that it is easy to forget how provisional its foundations remain. Our theories describe the behavior of matter and energy with remarkable accuracy, yet they do so by relying on conceptual frameworks that leave certain questions untouched. Among these unresolved issues, the nature of consciousness stands out as one of the most striking omissions. Physics tells us how particles move and fields interact, but it remains silent on why any of this should be accompanied by experience. Quantum theory, in particular, exposes cracks in the classical picture of reality. At the microscopic level, physical systems do not possess definite properties until they are measured, and outcomes can only be predicted probabilistically. This departure from classical determinism is not merely a technical inconvenience, it challenges our understanding of what it means for something to be real. The act of observation, long treated as a passive process, suddenly acquires a puzzling significance. Despite its predictive power, quantum theory lacks a fully satisfactory interpretation. Competing explanations coexist, each resolving some difficulties while introducing others. Some treat the wave function as a real physical entity, others as a tool for calculating probabilities, and still others multiply realities in extravagant ways. What they share is an inability to explain how definite experiences arise from the underlying formalism. The theory works, yet its meaning remains elusive. This incompleteness invites the possibility that something essential is missing from our physical picture. Consciousness may not fit neatly into existing theories because those theories were never designed to accommodate it. They abstract away the observer, focusing on what can be externally measured, while consciousness is intrinsically first person. The resulting gap may not be accidental, but symptomatic of a deeper limitation in our current approach. It is conceivable that future physical laws will differ radically from those we now accept, incorporating principles that link physical processes with conscious awareness. Such laws would not replace existing theories where they work, but extend them, much as relativity extended classical mechanics. In this expanded framework, consciousness might appear not as an emergent oddity, but as a fundamental aspect of reality, constrained and shaped by physical law. The history of science offers many examples where progress required abandoning comfortable assumptions. Space and time were once thought absolute, matter was once believed indivisible. Each shift revealed a deeper layer of structure underlying familiar phenomena. The difficulty of fitting consciousness into physics may signal a similar moment of transition, where current concepts reach their limits. Rather than forcing consciousness into theories that were never meant to explain it, we may need to rethink the foundations of those theories themselves. The strange features of quantum mechanics, long treated as interpretive puzzles, may be clues pointing toward a richer conception of reality in which mind and matter are not strangers, but intimately connected, awaiting a framework capable of describing both without reducing one to the other. The possibility that consciousness is a fundamental aspect of reality challenges one of the most deeply ingrained assumptions of modern science, that the universe can be fully explained without reference to experience itself. For centuries, physics has progressed by focusing on what can be measured from the outside, treating observers as interchangeable and irrelevant to the laws being described. This strategy has been extraordinarily successful, yet it may have achieved its success by deliberately setting aside the very phenomenon through which all knowledge of the universe is obtained. If consciousness is not merely a byproduct of complex matter, then it cannot be fully explained as an emergent accident. Instead, it would belong to the basic structure of the universe, alongside space, time, and physical law. This does not mean that every particle is conscious in a human sense, but rather that the capacity for experience is woven into reality at a fundamental level, becoming manifest only under certain conditions. Expanding physics to include consciousness would require a shift not only in equations, but in perspective. Current theories excel at describing relationship. between quantities, yet they remain silent about meaning, understanding, and awareness. A more complete framework might treat conscious experience as something that constrains physical processes, just as physical laws constrain motion and energy. In such a view, mind would not float above matter, nor be crushed beneath it, but stand in lawful relation to it. This idea also reframes the role of explanation. To explain something is not merely to predict its behavior, but to understand why it exists in the form that it does. If consciousness is fundamental, then explaining the universe without reference to it would be like explaining music solely in terms of air pressure while ignoring melody. The description would be accurate, yet incomplete. There is precedent for this kind of expansion. Concepts once thought extraneous to physics, such as electromagnetic fields or space-time curvature, eventually became central to our understanding of reality. They were not added as afterthoughts, but recognized as essential once existing frameworks proved insufficient. Consciousness may occupy a similar position today, resisting reduction because it demands a new conceptual role. Such an expansion would not undermine objectivity, but deepen it. Recognizing consciousness as fundamental does not collapse science into subjectivity. It acknowledges that subjectivity itself has lawful structure. The challenge lies in discovering those laws and integrating them with what we already know. In pursuing this path, physics would move closer to a unified account of reality, one that honors both the external world described by measurement and the inner world through which that description becomes possible. The ultimate aim would not be to reduce mind to matter or matter to mind, but to reveal the deeper principles from which both arise, offering a vision of the universe in which awareness is not an anomaly, but an integral part of the cosmos itself,